A river crossing dictates the daily rhythm of this valley. Before heavy materials arrive, the staging area requires order. Efficiency begins with a clean workspace. The build site sits deep within a forested network of dirt paths. Navigating these rutted roads demands a compact tractor with low-end torque. Every pound of cement and steel must be carried in before the real labor can even begin. Moving dense timber is an exercise in leverage and balance. They position the bench near the staging zone to serve as a sturdy platform for the heavy lifting ahead. Logistics form the invisible backbone of any remote project. A flatbed truck will ferry the heaviest loads closer to the water. A single bag of Portland cement weighs roughly 50 pounds. Stacking them requires careful weight distribution over the rear axle to prevent the vehicle from bogging down in soft mud. Concrete possesses tremendous compressive strength, but it shatters under tension. To survive the flex of foot traffic and seasonal flooding, the bridge requires a tensile skeleton. Coiled steel rebar will provide that flexibility. The transition from paved roads to shallow streams changes the equation. Here, the water dictates the access routes. The tractor's high clearance and aggressive tire treads allow it to bite into the rocky riverbed without stalling. It delivers the cargo exactly where the paved world ends and the jungle canopy takes over. Tipping the hydraulic bed saves hours of manual offloading. Now the material rests at the edge of the construction zone. Concrete is essentially artificial rock, and local sand serves as the fine aggregate. Moving it by wheelbarrow over uneven, sandy terrain is exhausting work. The narrow tire sinks into soft earth, forcing the builder to rely entirely on momentum and core strength to keep the load moving forward. Clearing the embankment establishes a solid, level footing. Loose topsoil must be stripped away to expose the compacted earth beneath, ensuring the future bridge approaches will not wash out during heavy rain. The stream provides an endless supply of water for mixing cement and cleaning tools. The existing crossing relies on weathered wooden planks laid over aging bamboo. Over time, moisture and rot inevitably compromise organic materials. To build something permanent, the old structure must first be systematically dismantled. Using a long-handled pry bar multiplies her mechanical advantage. The tool acts as a lever, easily lifting boards that have been wedged tight by years of expanding and contracting in the humid air. Removing the deck reveals the thick bamboo logs spanning the water. While bamboo possesses remarkable tensile strength, prolonged ground contact eventually invites decay. The new bridge will need a more resilient core. The cleared span exposes the underlying rock and gabion walls, providing a clean footprint for the new foundation. A precise measurement dictates the volume of materials required. Miscalculating the span by even a few inches compromises the structural geometry. Fresh green bamboo is dense and fibrous. Cutting it requires a heavy blade to slice cleanly through the outer silica layer without splintering the internal fibers. The cold mountain water offers a brief reprieve from the humidity. The new substructure begins as an interlocking grid. Vertical posts driven into the riverbed act as load-bearing columns, while the horizontal poles will support the massive weight of the wet concrete. Working directly in the current makes establishing a level plane difficult. Securing the joints with heavy wire binds the independent poles into a single framework. When weight is applied to the deck, the intersecting grid will distribute the downward force outward toward the rocky banks. A well-driven nail prevents the smooth bamboo joints from slipping out of alignment, holding the tension before the concrete locks them permanently in place. The dense, fibrous walls of the green bamboo are naturally resistant to crushing. By late afternoon, the skeletal spine of the crossing is fully established. A layer of heavy plastic sheeting goes down first, preventing the liquid cement from draining into the stream below. Then, the real reinforcement begins. Cutting thick steel by hand with rusted bolt cutters requires immense upper body strength, using the long handles as a high-ratio lever to force the jaws through the metal. She organizes the cut rods into a precise parallel formation. This creates the tension-bearing layer of the deck. The closer the bars are spaced, the higher the load capacity of the finished slab. every intersection of the metal grid must be lashed tight. If the rebar shifts while the heavy concrete is being poured, it creates dangerous structural weak points in the slab. She uses thin, annealed tie wire, a low-carbon steel that bends easily without snapping. The small twisting tool hooks the wire loops and pulls them rapidly into a tight spiral. Kneeling on the rigid framework, she methodically secures hundreds of individual joints. The metal hook spins, tensioning the wire just to the brink of failure before stopping. This mechanical grip ensures the entire grid acts as a single, unified mattress of steel. When a load presses down on the bridge, the concrete will resist the compression, while this interconnected steel web resists the bending forces that would otherwise tear it apart. With the final loops twisted tight, the armature is complete. The grid is now stiff enough to walk on without deflecting. A flat deck is not enough. A safe bridge requires sturdy side railings. To anchor those railings properly, she drills deep directly into the existing concrete abutments. The masonry bit grinds aggressively through the dense stone, producing fine white silica dust. Once the boreholes are cleared of debris, she hammers short vertical rebar dowels down into the foundation. These upright steel pins tie the new railing structure deeply into the solid bedrock. By wiring these vertical anchors directly into the horizontal deck grid, she guarantees the handrails will not snap off under lateral pressure. The entire system becomes one continuous cage of steel. Wet concrete is essentially a heavy, aggressive fluid. To give it shape, she installs rigid wooden planks along the outer edges to serve as formwork. These wooden sidewalls must be heavily braced to withstand the immense hydrostatic pressure of the wet cement pushing outward. The mixing phase requires careful chemistry. Concrete is a chemical reaction requiring an exact water-to-cement ratio. Too much water dilutes the cement paste and weakens the final slab, while too little makes the mix unworkable. The spinning drum folds the heavy aggregate together. The gravel and sand provide the volume and structural bulk, while the gray cement acts as the chemical binder, locking it all together. A metal chute directs the heavy, viscous flow exactly where it is needed, keeping the aggregate suspended evenly as it hits the rebar. Transporting the dense mud across the partially completed span is a race against the curing clock. As soon as water hits the cement, the hydration process begins, slowly turning the liquid into stone. The mix must be vibrated and pushed deep into the grid, ensuring the steel rebar is completely encapsulated. Any trapped air pockets or exposed metal will eventually lead to internal rust, which expands and cracks the bridge from the inside out. Using a flat shovel, she strikes off the high spots, roughing out a level plane. Working wet concrete is a heavy, rhythmic task. As the deck fills in, the sheer mass of the artificial stone begins to compress the framework beneath it. She finishes the edges with a hand trowel, sealing the pores and creating a smooth, weather-resistant boundary. Before the surface fully cures, the outer edges must be prepared for the decorative elements. She meticulously scrapes away excess mortar. A flat track is laid down along the rim, establishing a plumb baseline for the heavy balusters that will soon enclose the crossing. Creating identical architectural pillars requires reusable plastic molds. Before any concrete is poured, the interior of the mold must be coated with a release agent. This dark oil prevents the wet cement from bonding to the plastic walls, ensuring the delicate details strip away cleanly once the mix hardens. Assembled and locked, the hollow forms stand ready to receive the wet mix. The exposed vertical rebar rods act as anchors, waiting to interlock with the pillars. Off to the side, she begins batching a finer concrete mix. Casting intricate shapes requires a slurry with smaller aggregate, allowing the paste to flow into the tight corners of the mold without leaving pitted voids. She wheels the fresh batch directly to the line of empty forms. Pouring from a flexible hose grants precise control, preventing messy spills over the outside of the casing. The locking pins along the plastic seams must be tight. The hydrostatic pressure of the heavy mud will try to blow the two halves apart. Once set vertically over the exposed steel anchors, she packs the fine concrete down into the mold. The steel rod runs right up the center of the cavity, ensuring the finished pillar will not snap under lateral impact. Troweling the top creates a flat mounting point for the eventual handrail. This repetitive casting process demands patience. Every mold must be perfectly plumb, or the entire railing will lean. She works her way down the line, pushing heavy wheelbarrows of mud across the hardening deck. Packing the wet mix tightly eliminates hidden air bubbles. A continuous row of white plastic now borders both sides of the crossing. The structure must sit undisturbed, while the cement undergoes its chemical hydration. Demolding is the moment of truth. Popping the plastic clips releases the pressure, revealing the smooth, pale gray concrete underneath. Because the molds were properly oiled, the ornate architectural lines emerge flawlessly. The two-part shells are tossed into the shallows to be washed and reused. While the concrete is still slightly green, solid, but not completely rock-hard. She uses a small trowel to carefully scrape away any flashing left by the mold seams. Patching minor voids now ensures a monolithic finish. The bridge transforms from a raw industrial build into a refined piece of architecture. The rigid pillars provide a stable base, but the span requires a continuous handrail. Green bamboo returns to form the top rail. A high-speed power saw slices through the silica-rich stalks cleanly, preventing frayed edges. She pre-drills mounting holes to accept the rebar pins sticking out of the concrete cap, preventing the bamboo from splitting under tension. The hollow bamboo slides directly over the steel anchors, creating a seamless mechanical joint without visible fasteners. Adjusting the long poles requires a careful eye to maintain a perfectly straight line. Once slotted into place, the thick bamboo provides a smooth, weather-resistant grip that remains cool to the touch even in direct sunlight. Bare concrete is fundamentally porous. Leaving it unsealed invites moisture to seep in and rust the steel. She begins applying a high-adhesion exterior acrylic paint. These vibrant layers serve a dual purpose. They seal the microscopic pores of the cement against water intrusion, and they transform the heavy, monolithic stone into a vivid focal point against the jungle backdrop. Painting the cast floral reliefs demands a remarkably steady hand and a fine bristle brush. She carefully floods the recessed shadows with deep blue to make the raised crimson details pop. It is slow, meticulous finishing work that requires immense patience. The bright red cap edges create a striking, clean visual boundary, sharply outlining the structural geometry of the new crossing. Coating the fresh green bamboo preserves it from sun damage and insect rot. The alternating colored bands give the rustic materials a highly visible finish, signaling safe passage over the rocky water below. Sweeping away the construction debris reveals the final aesthetic. The bridge is no longer just a collection of mud, steel, and tied sticks. It is a completed thoroughfare. The bold colors stand in sharp defiance of the wild environment around it. A solid structure changes how the landscape is used. But a bridge is only as functional as the paths that lead up to it. The approaches must be stabilized to prevent the muddy banks from eroding. She uses a heavy spade to slice through the dense mat of tropical grass roots. Excavating a shallow trench creates a secure, below-grade bed for the concrete. If poured directly on top of the loose grass, the new path would quickly crack and slide downhill during the monsoon season. Sinking it into the firm subsoil locks it permanently in place. Scraping the trench flat ensures an even thickness for the concrete slab, preventing brittle weak points. Hours later, the approach route is fully excavated. For smaller finishing touches, a hand-mixed batch provides exact control over the consistency. But a long walkway requires a massive volume of material. The heavy wheelbarrow returns for the final push. Without the mechanical mixer, she utilizes a traditional ground pit method. Dry sand and cement powder are folded together first to ensure an even chemical distribution. A crater is formed in the center to hold the water, allowing the dry mix to slowly absorb the moisture from the inside out. It is back-breaking manual labor to pull the heavy, wet sludge into a uniform consistency. Every scoop represents heavy, clinging, dead weight. Moving wet concrete by hand demands a constant rhythm before the batch stiffens in the humid air. She shovels the dense mud directly into the wooden forms, outlining the new path. Crouching low, she uses a trowel to force the aggregate deep into the edges, eliminating dangerous air pockets against the timber boards. These rigid forms act as retaining walls, maintaining the fluid shape until the internal chemical cure locks the material into solid rock. The long pathway slowly inches forward across the dirt, firmly connecting the natural earth to the freshly engineered bridge. Floating the surface draws the fine cement paste to the top while pushing the rough gravel down. The wooden tool leaves a slightly textured, non-slip finish, essential for safe walking when the path inevitably gets wet from rain or morning dew. While the concrete is still pliable, she presses heavy, rounded river stones into the wet edges. This embeds them firmly, creating a durable and visually striking natural border. In the end, raw materials and immense labor become a permanent fixture, a place that connects, protects, and quietly endures.